I'm Yu Today I will give you an overview of ICME2022 Great Challenge Peer Competition. Summary of the 2022 Low-Power Deep Learning Semantic Segmentation Model Compression Competition for Traffic in Asian Country. Here is the outline of my presentation. First, I will introduce the competition and the data. Then is the summary of competition and model. The last is the competition conclusion. In recent years, semantic segmentation in computer vision is more accurate in deep learning. However, the computation of algorithm is heavier, and the embedded system is limited in computing capability and the memory consumption. If you want to put the algorithm in the embedding system, we have to do some effort to lighten the deep learning model. The left picture is an example of semantic segmentation. And in the right picture, we can see if you want a more accurate model, the computation time will be slower. The trade-off between speed and accuracy is the key of this competition. The left table shows the number of parameters, floating point operation per second, and storage of state-of-the-art model in semantic segmentation task. We are presuming lower number of operations while keeping the high accuracy. For example, UNet. That means higher memory demanding and huge computational costs in deep learning segmentation task. Also means more power and area in hardware design, resulting in lower performance. Here, we can see the estimated energy consumption of each arithmetic operation and memory access. We will face limited bandwidth of the memory in developing deep learning application, and memory access will increase power and latency a lot. In this competition, we need to segment three types of objects: main length, outer length, and some mark lines. And we use MediaTek Dimensity 9000 platform as the embedding system. The goal is to embedding semantic segmentation algorithm with fastest inference speed, low power, and acceptable segmentation quality. For the schedule of competition, the competition was held for 64 days, including 43 days of qualification competition and 21 days of the final competition. The competition is held by MediaTek Corporation and Pervasive Artificial Intelligence Research Labs, Ministry of Science and Technology in Taiwan. The dataset and the technology support in competition is provided by the Intelligent Vision System Lab in National Yangming Jiaotong University in Taiwan, AI System Lab in National Cheng Kung University in Taiwan, with strong National Jiaotong University Embedding Artificial Intelligence Research Center in Taiwan, the A19 Lab in National Yangming Jiaotong University in Taiwan. Next is the dataset information and how we label the data. We provide 35,500 images of training dataset from Berkeley Diverse Driving Dataset, 2,200 images for testing dataset. Our target object is main length, outer length, and mark lines, including double line, white line, yellow line, dash line. All the provided data are captured using a dash cam equipped on vehicle driving along the road in Taiwan, which consists of many car streets with lots of scooters and vehicles. These capture images including scenes in university campus, street, and highways, with various weather conditions like clear sky, foggy, and rainy. Daytime, night, backlight, and twilight are also included in the lighting condition of these images. We can see the example of training dataset and testing dataset. The testing dataset is more complex than the training dataset. The labeling tool we use is developed by ourselves, which calls Easy Label. It is mainly used to labeling video data. We can label the object property and the object behavior. Let's go to competition summary. There are two stages of competition. First stage is qualified competition. All participants submit their answer online. Then the score will be calculated. The top 15 teams would be qualified to enter the final round of competition. In the final competition, score of the submitted design will be evaluated over MediaTek Dimensity 9000 platform for the final ranking. Then we calculate the ranking score. All the evaluation metrics are linear distributed with their performance in the metric. The evaluation metrics including accuracy for 40 points, power consumption for 30 points, and inference speed for 30 points. Participants are encouraged to use lower bit representation in their design for better inference speed and model size. We have held 4 competitions. The first 3 years is object detection, and this year is semantic segmentation. There are 203 teams registered competition in this year. In the qualified competition, there are 22 teams submit their design, and the top 15 are selected to enter the final competition. This table shows the select team for the final competition. The highest performance is 0.72 of Team OKT 2077. In the final competition, only 8 teams submit their design. We evaluate the submit design over the MediaTek Dimensity 9000 platform. The final evaluation result is listed. The champion goes to OKT 2077 from Department of Computer Science and Information Engineering at National Central University. First runner-up goes to ASD-GGG from Department of Computer Science and Information Engineering at National Tsinghua University. Second runner-up goes to ICME Lab from Department of Industry of Data Science at National Chengkong University. The special award is absent. Model summary. We list top 6 award winners. Team OKT 2077 wins the highest accuracy with 72% of mean IOU and highest speed with 43 milliseconds. Team Polygon wins lowest power with 1,452 milliwatts. We also list the model information of top 6 award winners. We can see that in this competition, the basic model and the input size used by each team is different. Next, we will introduce the first, second, third, and fifth model. The overall best belongs to OKT 2077. They also won the highest accuracy and highest speed. They based on deep dual resolution network. They modify input size to balance the speed and the power consumption. The first runner-up goes to ASD-GGG. Their design based on UNet, which reduces the half of parameter of each layers and double the channel of each layers. Team ACV Lab, they won the overall second runner-up, and they paid lots of attention in reducing their model in the final competition. They proposed a boost semantic segmentation model based on STDCnet. They increased the diversity of the training sample to boost their model robustity with heavy data augmentation. Team Polygon, they won the lowest power consumption. Their model is based on the PSPNet and use segmentation toolbox to train their model. We list all adapted model and optimization technologies in the final competition. We can see 4 teams combine and rebalance the dataset, and 4 teams build their model to increase the inference speed and reduce the power consumption. Conclusion. In conclusion, the competition embedding deep learning semantic segmentation to pursue low power and fast inference speed while remain an acceptable accuracy. And we build up a testing dataset in Taiwan that contains completely raw conditions like mainland, outerland, and markline. There are in total 203 teams of participants register this competition, and 18 submit their final models for evolution in final competition. At last, congratulations to all the winners. The champion belongs to OKT 2077. The first runner-up team is ASD-GGG, and the second runner-up team is ACV Lab. Thank you very much for your attention.